Even I should take your attendance also. Okay. Okay. And when the lambda is the wavelength of the wave in the medium, when we talk about the medium, then the refractive index will come in the picture. So we will multiply with the n also here. So in that case, the phase difference is equals to 2 pi n lambda naught, because lambda naught is the wavelength in the vacuum with delta x. So let's simply derive it. Let's find out the path difference of a wave when it is traveling, okay, in a free space. So also you can represent this formula, phase difference over 2 pi. This is simple, you just divided 2 pi taken over here. Phase difference over 2 pi is equals to path difference over lambda. The path difference lambda correspond to the phase difference of 2 pi. Now you can see a figure over here. Here there is a source S1 and S2, very near source and identical one. Okay, so the wave is actually coming from the source S1 and reaching at point P. The distance is traveled by this wave is R1, and the distance is traveled by the wave which is coming from the S2 source is R2, and both are reaching at point P. So it is clear from this position of the crest or trough of the wave that the path difference between two waves, if we talk about the path difference between two waves, is equal to the wavelength. Okay, when we talk about with the formula, if wavelength lambda, and if it is a lambda, that correspond to the 2 pi. You can imagine, if I am talking about the complete lambda like this till here to here, then it then the phase difference will be 2 pi or 180 degree. Now suppose for a path difference of a delta, we will find out this delta path difference R2 minus R1, how this comes. Actually we want to find out this path difference here. Okay, so I will calculate a bit calculation here. Take my pen. Right. Okay. Okay, so I should say here, suppose a path difference of lambda, oh sorry, a path difference of delta, corresponding phase difference is phi. If phase difference is phi, so we can represent the relation between phase difference and the path difference is 2 pi by lambda into delta. That we can represent. Here, this is the phase difference and this will be the path difference. Let me write it here also. Phase difference equals to 2 pi by lambda into path difference. Now, what we will do, we will make it clear how it comes. So to make it clear, we will consider this figure over here. Okay, with the help of this figure, let's assume here there are two sources S1 and S2, which is shown in this figure. Okay, and the wavelength of these sources are lambda, and the sources are in phase. At S1, sources are in phase. Okay, they are in phase, not in out of phase. They are in phase, S1 and S2, and the frequency of the both the sources or both the waves, this first wave and the second wave. I think you cannot see with the white one, but I'm talking about the first wave and second wave. So I'm telling here both the waves are in phase. Lambda is the wavelength, and phases, they are in same phase, or it is called in phase. Okay, and the wave which is coming from both the sources, the frequency of the waves is defined by f. Therefore I can say, angular frequency omega can be represented by 2 pi f. Okay, if frequency of the wave is f, which is same for both the waves, so we can write the angular frequency omega is equals to 2 pi f, and they both the waves actually they travel at the same speed. And the propagation constant, we know the propagation constant can be defined by k, which is 2 pi by lambda, which is the propagation constant of a wave. So we can write wave equation for both the waves here. So let's assume the wave equation for first wave is y1 is equals to, so displacement is the y1, a is the amplitude, cos omega t minus k r1. R1 is the distance traveled by the wave till point P. So this y1 is equals to a cos omega t minus k r1 for the wave which is emerging from the source S1. Okay, source S1. Similarly, the wave which is emerging from source S2, we can write the displacement y2 is equals to a, amplitude is same, frequency is same here, phase is same here. A cos omega t minus k r2. This is the wave emerging from the source S2. Now here, this omega t minus k r1, which it is what? This is the phase. This is the phase traveling by the wave. So to simplify it, what I can assume here, omega t minus k r1 is the phase represented by phi 1. Similarly, omega t minus k r2 can be represented by phi 2. Therefore, if I want to calculate the phase difference, this is the phi 1 is the phase of the wave 1 and phi 2 is the phase of the wave 2. So if I want to calculate the phase difference, simply I will do phi 1 minus phi 2. If I will do phi 1 minus phi 2, which is simply a mathematical calculation, omega t minus k r1 minus omega t, this is minus, this minus omega t, and this will be plus. When you open the bracket, this will be plus. So this will cancel out. And you will have k will, you can take it common, k r2 minus r1. And also, should I put it here, say equation number 1, or this is 1, or I can say this is 1, this is equation number 2, and this is equation number 3. So from equation number 2, we can compare, or say equation number 1 says phi, which is the phase difference is equal to 2 pi by lambda delta. And we have calculated with these equations phase difference, which is, you can say delta phi. You can also represent in some textbooks you will find it delta phi or delta x. Okay, this is same, just the notation is different, meaning is same. So from equation number 1, if I compare equation number 3 and equation number 1, what will come? 2 pi by lambda delta equals to k r2 minus r1. 2 pi by lambda is the k. This will cancel out. So delta, which is the path difference, is r2 minus r1. This we find out the simply path difference. Okay, we will more elaborate it in a double slit experiment. Okay, and we will plot a tangent and will play with some trigonometry and we'll find out the path difference in the next slide. Okay, so here if simply we can find out this is the delta, which is the path difference between two waves, because here we have some assumptions. Yes, the phase is same, frequency is same, but when you are talking about any any double slit, Young's double slit experiment, you can take any two waves, their phase cannot be same. So in that case, how to find out the path difference? So whenever you are dealing with any application in the optics, or maybe first we will talk about the interference, then we will go to the diffraction part. So when the interference, when you solve any calculation or any applications, you will calculate the phase difference and path difference. Okay, that is the main result of it. So any doubt in this slide? This is very simple calculation, I think so. Okay, so this is given the relation. You should actually remain. What is the main thing here? Main thing is you should remember this formula. This formula can be asked. Okay, what is the relationship between path difference and phase difference? But the numerical will comes when we are going to solve for the double slit experiment in the next segment. Okay, that is important for the numerical purpose. Okay,
And can
so
we represent a wave in sine function also? A sine omega t minus kx1, like
yes,
this.
definitely you can represent it. It depends. You can represent it. Okay, so next is the double slit experiment. Here also I have taken some of the images, but you can draw it because we are going to solve a bit mathematics here. So this is a double slit experiment. Please draw these diagrams. I'm giving you 2 minutes here. So considering the same formula, we are going to calculate the maxima and minima conditions here in the case of this double slit interference pattern, which is coming out on the screen P. And we will also calculate the fringe width. Okay, so here you can see this graph very minutely. This is the source S1 and S2. Okay, we have drawn a perpendicular from S2 to S1. So S1B will be the path difference that we need to calculate here. Okay. So you can see S2, S1 and B. This is a right angle. Okay. And the distance between the source and the screen is capital D, and the distance between two sources, S1 and S2, is a small d. Okay. And from the center, the distance where we are taking a point P, where we want to find out either minima or maxima position, the distance is y. Please mute your mic, whoever is unmuted. So distance between central point to the point where at the screen where we are going to find out the maxima and minima position, is the distance is given by y. Okay. So these are the all the parameters in this figure. And with the center, this point is making an angle theta. If this is theta, this is the distance is very, very large. I mean, the distance between sources S1 and S2 is very less than compared to the distance between source to the screen. So should I write here? Okay. For your reference, I can say this D is very, very less than capital D. This is capital D, okay? And here a perpendicular drawn from the S2 to B. So this is, okay, I should take a different color here. How much this angle? This is the perpendicular from S2 to B. We want to calculate S1B here, which is the path difference, S1B. If we are drawing a perpendicular from S2 to B, this is a right angle triangle. So this will be the 90 degree. Okay. This will be the 90 degree, and we can assume this angle is theta. And this is, let me, if this is 90 degree, distance between S1 and S2 is D. Okay. So can you tell me what will be the S1B? If this is the right
D sin
angle
theta.
yes, D sin theta. Very good. This will be D sin theta. So sin theta will be S1B over D. That's we know. Fine. Let's do some mathematics and find out the maxima and minima condition. Okay. Now we know a relationship between path difference and the phase difference, which is phi is equals to 2 pi by lambda into delta. And I think maybe 3 class before we have find out some constructive and destructive interference, and there we have find out the phi values when the constructive interference will come and when the destructive interference will come. So when the phi will be integral multiple of 2 pi, then we will have a constructive interference, so 2n pi, and when the phi's value will be 2n plus 1 pi, that will give the destructive interference value. I think I should go back and tell you again. Okay. Yes. Can you see the phase difference values here?
Yes.
This phi is
Yes,
equals to 2 and pi.
yes, sir.
When we were having the constructive interference means we will have the maxima, and when the phi is equals to 2 n plus 1 pi, we will have the minima. Okay. So it's my request to all of you, please note down formulas, at least formulas, okay, that will help you out to solve the numerical, because just after whenever this topic will complete, the intensity, we will calculate the intensity of the de Young's double slit experiment, we will solve some numerical. So okay, so let's come here now. Fine. Here, this delta, I can rewrite this delta is equals to lambda over 2 pi phi. Now let's put the value when the maxima will come. Lambda over 2 pi and phi, when you put 2n pi, this will cancel out. When the path difference will be n lambda, you will have the maxima condition. This will be in the double slit experiment. Okay, this can be vary in other applications. And when lambda upon 2 pi multiply with the 2n plus 1 pi, what will come?
Minima. N plus 1 by 2 lambda.
N plus 1 by 2. Yes, lambda. Minima. ओके, ये तो हुआ आपका मिनिमा एंड मैक्सिमम कंडीशन फाइंड आउट करना. नाउ लेट्स गो टू दिस ज्योमेट्री trigonometry. Okay, what is inside this triangle and how to find out this path difference. Then we know this d is very less than this d, and we also said because when the small d is very less than d, means this distance is very large. The distance between the screen and the source, ये अगर बहुत ज्यादा है, so theta will be very less. Okay, theta बहुत कम होगा. So I should write on this condition, I should write this theta should be very less than 1. आई थिंक ये आपको दिख नहीं पा रहा है, मैं इसको so ये theta, this theta will be very less because this distance will be very large, okay, compared to this one. So this theta will be very less, and we know already इसको हम यहाँ पे बाई पार्ट कर देते हैं, ठीक है. We know S1b is equals to d sine theta. If S1b is equals to d sine theta, so sine theta is equals to S1b over d, that we can write. Now what we can do, sine theta is equals to S1b over d. I should give some equations here again to calculate it. Equation number 1, this is equation number 2, this can be equation number 3, And this is equation number 4. So can I write from equation number 2 and 4? Equation number 2 and 4. Can I write n lambda equals to d sin theta? लिख सकते हैं? Because
Yes.
n lambda is the path difference. This is our path difference, which is S1B, right? All same, है ना? From here, sin theta is equals to n lambda over d. This is equation number 5. And we are assuming already this d is very, very less than capital D. If small d is less than capital D, very, very less than capital D, so now you will tell me what will be the tan theta here in this triangle. मैं आपको बताती हूँ actually. I have to change every time. Okay, in this triangle, this y, this d.
Y by capital D.
Y by capital D.
Very good. Yes, exactly. Let me come with pen. Okay, tan theta will be y by capital D. So theta is very, very less than 1. So can I equate tan theta equals to
Theta.
sin theta? Theta, yes, obviously theta also. और उसी को हम sin theta के इक्वल भी कर सकते हैं. So अगर हम इसको sin theta के इक्वल कर सकते हैं तो ये equation 5 है आपकी, this one, and this I can give say equation number 6. So I can equate equation number 5 and 6 over here, both the equation. From equation 5 and 6.
Ma'am.
हाँ बोलिए.
Ma'am, can you please explain what did you do in equation number 6?
Equation number 6. Equation number 6 is the tan theta. Okay, so theta missing हो गया. Tan theta. This tan theta we have taken from this triangle. 1 minute. Okay. P. You can assume some point over here. This is your y. And this point. And this theta. Okay. So पहले आप मुझे ये बताइए what is tan theta? Tan theta is the opposite upon adjacent, right? In a triangle.
हाँ, perpendicular by base.
Yes, ma'am.
है ना? तो opposite वो क्या है y और
Y.
बेस क्या है आपका d?
E.
बस
हाँ,
वही
y by
लिखा.
D.
हाँ वही लिखा है मैंने, समझ गए?
वो थीटा मिसिंग था इसलिए थोड़ा कंफ्यूज हो रहा था.
हाँ नहीं वो मैं सॉरी वो मिस हो गया मेरे माइंड में है लेकिन मैंने लिखा नहीं.
हाँ कोई.
हाँ. Okay, so now जगह बहुत कम रह गई है. So can I come over here? This here. Okay. So what I'm doing here, I'm equating equation number 5 and 6. If I'm equating equation number 5 and 6, then it will give me y over capital D equals to n lambda over small d. This will give you y is equals to n lambda capital D upon small d. And what is n? N is the number of fringes. Okay, so n is the 0, 1, 2, and so on. So if I say this is yn, it is nth fringe or nth point where we are getting a fringe. Okay, it is nth fringe. Now if I want to calculate the fringe width here, because this nth fringe which are getting at point P, it can be dark fringe or bright fringe. But you can see here, this is fixed value, n lambda d upon d. So these fringes are equally spaced. There is any any kind of in this formula, not any kind of parameter that can be changed. It is all fixed. If the wave is coming with some source, the lambda will be fixed. The distance between source and the screen will be fixed. The distance between two sources will be fixed. What will change only? The n, which is the fringe number. So I can calculate the fringe width here also. So we can say these fringes are equally spaced, and the distance between two consecutive fringes, either they are bright or they are dark fringes, can be given by a beta. This is a fringe width, which is given by, say, I should say n plus 1 fringe, okay, minus yn. There is a nth fringe, and then there is a n plus 1 fringe. So what will be the difference when you put the value here, n plus 1 and n? Can you calculate it?
Lambda into d by d.
Very good.
Lambda d by d.
Lambda d by d. So you can see here the fringe width is not depending on anything. It is in it. This is the expression which is of the fringe. कौन से नंबर की फ्रिंज है, nth फ्रिंज है, 6th फ्रिंज है, 8th फ्रिंज है, 10th फ्रिंज है. It doesn't depend on the fringe, because so that's why the fringe width is equal for all the fringes. Whatever maxima and minima fringes are making on the screen, okay, so the fringe width of each and every, so fringe width for each and every fringe will be the same. Or we can say all the fringes are equal in width and independent of the order of the fringe. Okay, so beta is only depends on the lambda. Beta is only depend on the distance between screen and the source, and beta is, or we can say, proportional of the 1 over d. It doesn't depends on the order of the fringe. So the fringe width is the same for all. So I should say here, please remember the formula of yn. Remember the formula of fringe width here. Okay, these are the formula. We are going to solve some numerical maybe in the next class. Okay, here I have calculated everything, but once I will click here, you will get the calculation as it is, because I have made a PPT as well, but मैंने आपको सब अभी यहाँ पे solve करके दिखाया है with hand. So please note down all this. I am giving you 2 minutes, then I will switch to the PPT, because it's already written in the PPT as well. What I am telling, मैंने इस पे आपको करके बताया है, पर ये ऑलरेडी पीपीटी में है. मैं आपको बता देती हूँ, आप इसको पहले नोट डाउन कर लीजिए.
Ma'am,
Yes,
ma'am, y is the path difference, right?
path difference is the delta.
And ma'am, what is y?
Path difference ये रहा आपका S1b. 1 minute. Y is the distance from center to the point where we are calculating the not right now, no intensity, but we will calculate the intensity. So y is the distance, or we can say the displacement, or the distance from center to the fringe.
Okay.
This, है ना? And path difference is here, S1b. This is the path difference delta.
Okay.
I have elaborated this diagram in the the below one also. You can see the below diagram here, the path length difference. It can be also represented by delta L in some textbook. You will find in delta X also, delta L. We are taking only only delta here. So don't be confused. Keep one notation in your mind and follow the complete calculation.
Ma'am,
Okay,
this y that we have calculated n lambda into d by d, this is only for maximas, no? For the minimas, there is will be a different equation, or this will be applicable?
this will be applicable because that's what we are, finding out here. This beta, this fringe width is not depending on
No,
the
ma'am, not for
order.
fringe width. I'm
हाँ
just
हाँ,
talking for that y. Y only, only y.
only y.
Yes, ma'am.
Okay.
If we put the value like 1, 2,
Yes,
3,
yes,
it
yes.
will
When
only give the distance of maximas or only maximas, no?
yes, only maxima. For the minima, you need to say
Different
n plus
equation.
half. है ना? हाँ,
हाँ.
equation number 3. हाँ, बिल्कुल बिल्कुल. So remember all these values. So what will come at what value the maxima will come, at what value the minima will come. So equation 2 and 3 are equally important here. Okay, that will also help you to solve numericals.
And how we are saying that the theta is very small?
Because the distance between sources and the distance between source to screen is very large. See, the distance between sources S1 and S2 is a nanometer order. Okay, 10 to the power minus 9. When you are going to once the university will open, you are going to do all the experiments as well. So you can see the distance between sources is very small. It's almost in the nanometer order, but the distance, we can say this will be in a centimeter. Okay, that's why we can say we can put it as a negligible, like this distance is very less. If this distance is very less, then the p will be like here, close to the central. So we can say yes, theta will be very less. Okay, ये जितना दूर जाएगा थीटा उतना ही कम होता चला जाएगा. Got it? या अभी डाउट है आपको?
मैम पी को हम ऊपर भी तो ले सकते हैं.
हाँ, कहीं
इसके
भी ले
अंदर.
सकते हैं, कहीं भी ले सकते हैं आप.
तो
We can
इसमें
assume
अगर
any.
पाई अगर अपन काफी बड़ा कर दे तो उस केस में ये सारे फॉर्मूलेज एप्लीकेबल नहीं होंगे ना, क्योंकि अपन ने थीटा को छोटा लिया है.
थीटा को छोटा लिया है क्योंकि थीटा को हम इसलिए अज्यूम कर रहे हैं छोटा, बिकॉज हम डिस्टेंस को कंसिडर कर रहे हैं, है ना. और अगर हम डिस्टेंस को कंसिडर नहीं करेंगे तो आपको कोहेरेंट सोर्सेज नहीं मिलेंगे. कोहेरेंट सोर्सेज coherent sources आपको either you can when we will discuss the coherent sources in the next topic, either we can get the coherent sources from the single source or maybe very less distant sources which is coming out from the a single source. अगर मैं एग्जांपल लेती हूँ येलो लाइट का, सोडियम लाइट का. Okay, we say sodium light is a monochromatic light, but not. Sodium light is not a monochromatic light. There is a difference of 6 angstrom between so sodium is having a doublet. So अगर हम उस पॉइंट पे जाते हैं, वहां से कंसिडरेशन शुरू करते हैं. सो वो डिस्टेंस है सोर्सेस का, वो 6 एंगस्ट्रॉम होता है, 10 टू पावर माइनस 10 ऑर्डर का. तो ये डिस्टेंस ऑलवेज वेरी लेस, दिस डिस्टेंस इज ऑलवेज वेरी लेस. अगर ये डिस्टेंस बहुत कम होगा, वो चाहे आप इसको सेंटीमीटर में लें या मीटर डिस्टेंस पे लें, आइदर 1 मीटर डिस्टेंस पे आपने स्क्रीन रखा हुआ है, तब भी थीटा आपका लेस होगा, चाहे आप पी को शिफ्ट ऊपर शिफ्ट करें या नीचे शिफ्ट करें. और उसमें आप जब कैलकुलेट करेंगे तो अगर थीटा आपने लेस प्रेडिक्ट किया है तो आपकी कैलकुलेशन विल कम मोर और लेस सेम. एंड दिस इज द एक्सपेरिमेंट एक्चुअली बाय यंग्स. So for the different experiment, there is a different scenario. We will discuss in different applications like Michelson interferometer में different scenario है, air wedges में different scenario है. So ये double slit experiment है. Okay, we are taking up particular experimental conditions. We are not generalizing it, right?
ओके मैम.
हाँ.
मैम इस एक्सपेरिमेंट में ये भी तो केस आता होगा जहाँ पे डी साइन थीटा को हम एग्जैक्टली टेन थीटा नहीं एज्यूम कर सकते था.
Exactly 10 थीटा assume नहीं कर सकते हैं,
क्योंकि तब थीटा बड़ा हो जाता होगा तब इस केस में.
उसी क्वेश्चन का तो मैंने रिप्लाई किया है अभी कि यही सेम रिप्लाई किया है मैंने कि स्क्रीन आप 10 थीटा को वैसे भी आप सिंपली ले लीजिए. व्हाट विल बी द 10 थीटा? अगर थीटा एंगल ज्यादा है तो 10 थीटा आपका y/d होगा, राइट?
मैम तब साइन थीटा के अकॉर्डिंग तब मुझको करना पड़ेगा ना, तब मैं साइन थीटा को टेन थीटा नहीं लिख सकता ना।
हाँ, तब आप उसको इक्वेट नहीं कर सकते हो, पर साइन थीटा अगर थीटा
तब
आपका
जनरल
बड़ा
प्रोसेस
हो
से
गया।
जाना पड़ेगा।
हाँ, क्या बोल रहे हैं?
तब मैम जनरल प्रोसेस से जाना पड़ेगा, साइन थीटा को जो फिगर में मुझको साइन थीटा मिलेगा बाय कैलकुलेटिंग इट ट्रिग्नोमेट्रिकली, तो
Okay.
वो फिर यूज करना पड़ेगा मुझको।
Okay, yes. Here we are simplifying a few things to solve or to calculate the conditions. Yes, we are assuming few things here. I'm agree with you, totally agree with you. We are assuming, so as it is done, experimentally proved that we are discussing, we are not going to the extreme conditions. There will be always a limitations with each and every experiments. Okay,
Yes, ma'am,
you are
exactly.
absolutely right. Yes, yes, you are exactly right. I'm not denying it. It can be possible. Because initially I told you we are assuming these conditions, then only we can solve out and we can find out such formulas and the fringe width as well. I think आपने अब तक you have noted down, huh? Okay, so
Yes, ma'am.
okay, so there's something overlapping here because I have already made a PPT, and so this is already done. Okay. Okay, so you will get your PPT in this form as well. Okay, but I have solved it here that I will remove it or I should remain it. आप ही बता दीजिए जो हमने किया है उसको हम remove कर दें या because already done here. मैंने आपके लिए पूरा proper PPT बनाया हुआ है. So okay. यहाँ
रिमूव
थोड़ा हाँ ये रिमूव कर देंगे हम, ठीक है. Somebody telling something? Okay, fine. Fine. So in the next class, maybe I can assign you some numerical as well tomorrow in the tomorrow class. Okay, we will solve some numerical based on these formulas. So please note down all the formulas.
आपने ये जो आपने जो पेन से मतलब आपने जो लिखा है ये आप रिमूव करेंगे या वो नॉर्मल जो आपने जो पीपीटी में जैसे रखा था वही रखेंगे?
मैं वही पूछ रही हूँ आप लोगों से, what you want.
तो
If I can, what I will do on only on the single slide, whatever in the text, I can remove that one. Okay, only the text part जो इसमें केवल written है और ज्यादा कुछ लिखा हुआ नहीं है, केवल explanation है कि path difference इतना है and this is a distance, that's it. Okay, but ये यहाँ पे as it is रहेगा and in the next slide will be as it is like this. Okay, are you agree with me?
Yes, ma'am. मैम एक डाउट है
Yes, ma'am.
लेक्चर
हाँ.
रिलेटेड नहीं है मैम. वो
हाँ.
इंट्रा इंस्टीट्यूट स्लाइडिंग राउंड है मैम, उसमें
1 minute क्या पूछ रहे हैं?
वो इंट्रा इंस्टीट्यूट स्लाइडिंग राउंड है ना मैम, वो अपग्रेडेशन के लिए.
ओके.
तो मैम उसमें अगर हमने अपग्रेडेशन के लिए डाला ब्रांच के लिए तो वो डिग्रेड तो नहीं होगा ना हमारा?
ओके, एक्चुअली डिग्रेड अपग्रेडेशन के लिए डाला है आपने तो डिग्रेड तो नहीं होगा आपका. इफ देयर विल बी ऑप्शन यू विल गेट अपग्रेडेशन, इफ देयर विल बी नॉट देन यू विल बी देयर एज इट इज. ओके
मैम एक्चुअली उसमें दिखा नहीं रहा है अभी स्लाइडिंग राउंड के लिए चॉइसेस फिल करने के लिए.
Okay, so see, one single point contact person is the Dr. Anand Pandey. I think you have receiving emails from him directly many times. I guess so. He is the BTech coordinator, first year coordinator. So academic part right now. So either if you have any doubt, any kind of a doubt, you just simply write an email to him. You must have his email ID, right? पांडे है आपके पास? ईमेल आईडी होगा आपके पास क्योंकि आप उनसे ही आपको रेगुलर ईमेल्स मिली होंगी बीटेक रिलेटेड. सो अपग्रेडेशन का जहां तक पॉइंट है वो मैं यही कह सकती हूँ कि अभी अगर आपको विजिबल नहीं हो रहा है तो आई थिंक देयर शुड बी सम डेडलाइन व्हेन इट्स गिवन टू द स्टूडेंट्स. Anyone telling
Ma'am,
any
actually it's enabled for MIT Manipal students and it's till 13th only.
1 minute.
स्टूडेंट्स को ईमेल करना है, ईमेल दिया गया है उसमें मुझे स्टूडेंट्स को ईमेल करना है अपने इंटरेस्ट स्लाइडिंग के लिए.
Okay, fine. So why don't you simply write to the Dr. Anand Pandey? That will be the single contact person. I think so. He will answer you rightly. Okay, because I cannot or either one thing I can ask him and I can reply you tomorrow. That's another point. So your question is the upgradation is not visible over there. That's your question or what?
वो सिर्फ MIT वालों के लिए ही खुला है, मणिपाल वालों के लिए ही खुला है इंटरेस्ट स्लाइडिंग काउंसलिंग के इसमें. बाकी जो MUG और सिक्किम वाले हैं उनको ईमेल दिया गया है, उसमें ईमेल करना है.
अच्छा ठीक है. So you are giving the answer already. So आप क्वेश्चन कौन पूछ रहे थे
Okay.
अभी मुझसे? Okay, Jalaj, you got the answer?
Yes, ma'am.
है ना?
और हाँ मैम, मेरा तो EC दिखा रहा है लेकिन मेरा तो ऑलरेडी अपग्रेड हो चुका है CC में, तो वो कब अपग्रेड मतलब चेंज होगा मेरा?
अच्छा, अपग्रेड विजिबल नहीं हो रहा है. So wait for some time and
वैसे फर्क तो नहीं पड़ता फर्स्ट ईयर के लिए, सेकंड ईयर से मैटर करेगा.
हाँ, फर्स्ट ईयर डजंट
Yes,
मैटर.
ma'am, मेरी भी ब्रांच अपग्रेड हुई है, लेकिन मेरी बात हुई थी सर से, उन्होंने बोला कि आप चिंता मत करिए, बाद में हो जाएगा, अभी बहुत हौच पौच चल रहा है सब कुछ, जब टाइम मिलेगा तो हो जाएगा, उसका कोई इशू
Still, yeah, there are so many things are going on. Still, admissions are going on. New students are joining. Still joining. So once the admission process will be closed, maybe after Diwali, and then they will look into this matter. They will do everything. Okay.
और मैम दिवाली की छुट्टी का
दिवाली की छुट्टियां आपकी
अभी
फ्राइडे से है?
आया तो है, फ्राइडे और मंडे है तो.
मैम पहले ही छुट्टी हो रही है.
कहाँ पर आया है?
अरे वो हॉलीडे कैलेंडर में दिखा हुआ था.
हाँ, you check your holiday calendar, please. Okay, so tomorrow is only the class, and from Friday, Friday onwards, you have holidays. Friday to Monday.
Thank you, ma'am. Thank you,
Okay.
ma'am.
Okay, guys. So enough for today. Take care. Enjoy your
Thank you,
day.
ma'am.
Thank you,
Thank
ma'am.
you,
Welcome.
Thank you so
Bye-bye.
much, ma'am.
Thank you, ma'am.
Bye,
Thank
ma'am.
you, ma'am.
Bye, ma'am.
Bye, ma'am.
क्या कहाँ गया वो? आ गया।